Today's lecture is about logarithm function graphs. So in this lecture, I will explain how to sketch the following logarithm function equation. But before doing this, there is one thing you should know. There is inverse, about inverse. The logarithm function is an inverse of exponential function. As I have already mentioned, the inverse function is a function reflected through y equals x, which plays a role of a mirror. So this is y equals to the power of x graph. This is y equal log base a of x. And in case of exponential function graph, it has coordinates here 0 and 1, and its x-intercept 1 and 0. Therefore, we can realize two graphs have a relationship of inverse. For this reason, when you are going to transform y equals a to the power of x into a logarithm function graph, you should replace y by x equals x by y, and then take log base a of both sides and bring down y. Therefore, y equals y log base a of a equals log base a x. But this one is 1. We have already learned. Therefore, y equals log base a of x. We have got this one, logarithm function graph. Conversely, when we gonna transform y equal log base a of x into exponential function equation, you should replace y by x equal x by y, like this. And x has 1 behind itself. 1 is the same as log base a equal log base a of y. Bring it up here. Log base a of a power to the power of x equal log base a of y. Cancel. Therefore, y equals log to the a to the power of x. Okay, if we understand this property between two functions y equals log base a of x and y equals a to the power of x, you could sketch both graphs very easily. Let's sketch y equals log base 10 of x. Y equal log base 10 of x. We know already its shapes. Therefore, okay, this graph passes through these coordinates of x-intercept 1 and 0. And this line is asymptote line, x equals 0. And this is, but in this case, you should mark at least one point on the curve. And x equals 2, y equals log base 10 of 2. This is important. And the next question, y equals log base 2 of x minus 1. Y equals log base 2 bracket x minus 1. And its rough shape in case of log base 2 of x, this one is y equal log base 2 of x. Its coordinates passing through 1 and 0. But this means that the graph will be shifted to right hand side by 1. Therefore, and asymptote will be here. This is y equal log base 2 of x minus 1 graph. The next one, y equals log base 3. Y equals log base 3 of x plus 1 plus 2. And its shape only you think just this one. This was 1 and 0, and y equals log base 3 of x. But this graph will be shifted to left hand side by 1 because of this, by 1. And this graph will be moved up by 2, 1, 2. Therefore, okay, we can know its coordinates 0 and 2, but we don't know its coordinates. So y equals 0, x equals blah blah something. So you should find its coordinates. How can you find its coordinates? At this point, this is the intercept, x-intercepts. So therefore, y equals 0. The y equals 0 equals log base 3 of x plus 1 plus 2. And subtract 2 from both sides. Minus 2 equals log base 3 of x plus 1. And minus 2 is the same as log base 3 of 3 equals log base 3 of x plus 1. And minus 2 will be here. And log base 3 of 3 to the power of negative 2 equals log base 3 of x plus 1. They cancel. Therefore, x plus 1 equals 3 to the power of negative 2. Therefore, x equals 3 to the power of negative 2 minus 1, x equal 1 on 9 minus 1 equal minus 8 on 1 equals minus 8 on 9. Therefore, its coordinate, x coordinate is minus 8 on 9 and 0, and but its asymptote is y x equals minus 1.